So, last time, diniscuss natin yung about sight distances. So, kailan natin ginagamit ang sight distances? Kapag may obstruction. So, kapag may obstruction, we need to design the highway or yung roads natin for safe sight distances para hindi mag-collide ang mga sasakyan or kung may object along the way. So, examples of situations wherein nagkakaroon ng obstruction. So, kapag sa mga kurbadang daan, tapos merong obstruction, for example, ganyan. So, merong sasakyan dito, papunta siya, forward, and then may sasakyan dito, forward din siya. So, silang dalawa hindi agad yan magkakakitaan kasi merong obstruction yung object natin. So, in highway engineering, we need to get yun ng safe distance kung saan makikita nila yung kasalubong nila or makikita nila yung object na along its way. So, ito yung safe na distances. Itong distance na to, ito yung safe na distance kung saan makapag-react, mapaperceive at makapag-react yung driver para makapag-adjust siya sa driving niya para hindi niya makolide yung object or another vehicle. So, another situation na may obstruction are sa mga intersections. So, kung may sasakyan dito, papunta doon, and another dito, papunta sa ganyan, hindi sila agad makikita dahil nga, again, may obstruction. So, we need to get itong distance na to kung saan makikita nila. At dapat yung distance na yan is may enough time para makapag-react nga at ma-perceive ng mga drivers yung object or vehicle na makakasalubong nila. Another obstruction kapag summit curve yung daan. So, kung meron kang sasakyan dito, paakyat, merong sasakyan or in this side na paakyat din, hindi sila agad magkikita because again, may obstruction. At this point lang sila magkikita. So, doon pa lang nila makikita ng isa't isa. And this distance should be safe. So, safe sight distance yan para ma-perceive nila ang isa't isa and makagawa sila ng action to avoid collision. So, yun ang gamit ng sight distance. So, remember, kapag may obstruction, you need to design yung safe sight distance. Ngayon, next na geometric design for highway is yung alignment. So, alignment, we design alignment sa highway when there is change in elevation or in the direction. Kapag elevation ang may change, vertical alignment ang tawag. Kapag direction ang change, horizontal alignment ang gagawin, ang tawag. So, what is not vertical alignment? Paano nagkakaroon ng change in elevation? So, for example, meron kang daan, straight na daan, and then may sasakyan ka. What if kailangan niyang umakyat at makapunta dito sa upper part ng daan? So, meron kang change in elevation. So, this needs vertical alignment. So, pag vertical alignment, we use parabolic curves. And then, let's introduce yung horizontal alignment. Kailan natin ginagawa yung horizontal alignment? Ang sabi dito, kapag may change in direction. Paano yung change in direction? Kung meron kang straight na daan, ang sasakyan na magta-travel dyan ay going on a straight direction din. So, what if liliko na ang daan? So, may change in direction ka. So, these roads, you need also to design them sa horizontal alignment. So, for horizontal alignment, ginagamit natin mga circular curves. So, So, paano yung circular curves na yun? Ini-smoothen natin ang mga corners using circular curves. And this topic, horizontal alignment, ito yung na-discuss before sa surveying subject natin. Diba? Doon nandun yung simple curves, compound curves, and reversed curves. Those are horizontal alignment. Yun yung meron kang radius dito. So that's horizontal alignment and circular ang curve doon. Circular curves. So sa highway engineering, we will discuss yung vertical alignment. So how do we design yung vertical alignment? We use nga yung parabolic curves. So ibig sabihin, ito yung mga corners na ito. Ito yung i-smoothen natin with the use of parabola, ang parabolic curves. So let's use red pen. So this we smoothen them using parabolic curves. So pwedeng ganyan. So dito pa lang magi-start yung parabolic curve. Dito, so ibig sabihin sa part na to straight siya. Sa part na to straight siya. And then ito yung mga naka-parabolic lang. Pwede naman yung case na mag-start ka ng kumbaga, or dito parabola silang lahat hanggang dito rin, kumbaga end point ng parabola 1 is starting point ng parabola 2 dito. Pwede din yun, magkadikit. Straight ka muna dito, parabola ka dito, parabola na baliktad, and then straight. So pwede din yun. Or pwede rin yung straight dito, parabola, and then straight muna, then parabola, and straight. So this is yung vertical alignment. We aim to smoothen yung flow ng daan when there is change in elevation. So vertical alignment, we use nga parabolic curves, and then parabolic curves, meron tayong ginagamit na symmetrical curves, and meron another type na asymmetrical curve. So symmetrical sila. Asymmetrical, hindi symmetrical yung curve natin. So let's discuss muna yung symmetric parabolic curves. So we need to recall yung mga past lessons natin, mga equations sa parabola. So equation 1, this one, and then yung relationship ng vertical and the horizontal dimensions ng parabola. Then recall also sa math, slope is equal to rise over run, and then sa calculus, slope is also defined dy over dx. And then also sa geometry, similar triangles. We will use yung principle ng similar triangles. And then in surveying, recall yung mga elevations at surveying and yung stationing natin. So typically, per station is 20 meters. So let's have an example of a parabolic curve na daan. So sa umpisa, of course, meron tayong dinedesign na terrain. So kunwari, ang terrain mo is ganyan. So ito yung terrain na papa-smoothen mo ang travel. So we will use parabola. Diba na-discuss na natin dun sa passing side distance, kapag may slope ang terrain mo, so ibig sabihin may grade ka. So this is upward. So it is a positive grade. Dito is downward. Meron kang negative grade. So let's say meron kang G1 dito, and then meron kang G2 dito. G2 is negative dahil downward. G1 is positive dahil upward. So ito this is called the backward tangent. This is yung forward tangent. Now, let's smoothen using a parabola. So, let's draw a parabola dito. Kung start ang parabola mo, end ang parabola mo dito. So, this is your parabola. Now, we can use these properties of parabolic curves para ma-identify natin yung mga items or parameters involved in solving parabolic curves. So, number 1, L is equal to the horizontal distance from PC to PT. So, what is PC and PT? Yung mga points na to, PC, wait lang. So, this is PC, and then this is yung PT, start and end. Then, there is another intersection here, we call this PI. Okay, so sabi niya, property 1, L is equal to the horizontal distance from PC to PT. So, when you dimension for the length ng curve, it is a horizontal distance from PC to PT. So, this is your L. Hindi mag-a-align ng length dito sa sa PC to PT. Hindi siya pa ganyan. Hindi siya a-align doon. Aligned ang length ng curve sa horizontal. This one. So, number 2 property, PI is midway between PC to PT. So, PI is midway between PC and PT. So, ito yung PC, ito yung PT. Pag si PI, binaba mo ganyan, dimension mo like this, it is midway ng dalawa, meaning this is L over 2, this is also L over 2. So, that's the second property. So, third, the curve is midway between PI and yung midpoint ng chord ng PC to PT. So, magko-chord daw tayo from PC to PT. So, ito yung chord, yung midpoint daw ng chord. So, this is the midpoint. That midpoint is midway between PI and dito. So, midway yan. Ibig sabihin, may equal dimension na mangyayari dito. Ang dimension na to is equal sa dimension na to. So, equal silang dalawa. So, this is the basic property ng mga parabolic, symmetric parabolic curves. So, symmetrical dahil nga L over 2, L over 2 dito. Equal ang distance sa left ng PI, equal siya sa distance sa right ng PI. So, how do we solve these problems involving parabolic curves? So, in highway engineering, kapag nagde-design ka ng curves, you need to know yung locations ng kada point sa curve. So, these are the points sa curve. This point. Lahat ng points along the curve, dapat alam natin. Ayan. So, unang-una, syempre, yung highest point niya. Kung summit curve ka, you should know nasaan yung highest point sa summit curve mo. So, say for example, let's call yung highest, let's dimension, kunwari, ito yung highest point. And from PC, let's dimension yung horizontal dimension ng highest point. Let's call it S1. And then, from PT, let's call it S2. So, ito yung highest point. Let's call this, ano bang maganda? Highest point. Let's call it B. Point B. So, point B is our highest point. If it's horizontally measured from PC, we call it S1. Kapag from PT, we call it S2. Now, let's try to solve. Formulate. Gawa tayong formula. Let's derive yung formula on how to get S1. using yung basic math natin, which are this one. And syempre, surveying. So, S1. Una natin isolve si S1. So, since parabola tayo, let's use yung equation ng parabola, which is y equals kx squared. Y is equal to kx squared. So, kapag dinerive natin to, d over dx, this will be dy over dx equal to k 2 times x. So, recall, dy over dx is slope, diba, sa calculus, and slope for a parabolic curve is yung grade. So, since from PC tayo, let's, S1 is from PC, ang grade na gagamitin is grade 1. So, let's substitute. Ano ba ito? G1 is equal to 2kx. And then, what is x? Siya yung horizontal distance ng highest point to PC, which is ito, S1. So, this is S1. So, substitute na natin siya dito. Let's go, note this as S1 na. So, ayan meron na tayong equation with, with the relationship ng G1 and S1. Kaso, ano yung K? Wala naman tayong K. So, let's derive an equation to get K. So, let's use yung S2. So, let's get yung S2. So, yung equation ng parabola ulit, kx squared. Pero since nandito tayo sa side ng S2 or side ng PT, negative tayo dyan since downward ang grade natin. So, let's derive d over dx. So, meron tayong dy over dx equals negative k2 x. So, remember again, this is a slope. Then, since nasa side tayo ng PT, ang grade doon is G2. So, let's write, this will be G2 then. Sorry. And then, sa right side ng equation, ay, ito pa ng x. Ano ang x natin sa side ng PT? It is S2. This is S2. So, let's write yung second equation natin. This will be G2 equals negative 2K S2. So, meron na tayong equation, another equation. So, we are doing this para makancel yung K. So, let's find a way to cancel K. So, what we can do is divide natin yung dalawang equations. Cancel yung K. Divide mo sila. Cancel itong dalawa. Ang natitira is G1 over G2 equals negative S1 over S2. So, G1, G2 are given. S1 is, may nakuha na tayong S1. Pero, as you can see, dalawa yung variable natin. S1 and S2. So, since we're deriving, di ba, S1 muna, let's express S2 in terms of anong pwede nating gawing equation for S2. Di ba kapag yung length, may minus natin ng S1, this will be S2. So, let's substitute this value. Instead of S2, let's use L minus S1. So, our equation will be negative S1 over L minus S1. So, isa na lang yung variable natin sa equation. It's S1 na lang. And this one, we need to isolate para ma-form natin yung equation for S1 lang. So, what we can do, cross multiplication, G1 times L minus S1 equals, nasa na yung negative? Dito yung negative, and then S1. Okay. Distribute natin to. G1 L minus G1 S1 equals negative G2 S1. So, isolate natin si S1. Ilipat natin doon. So, this will be positive na. So, G1 S1 minus G2 S1 equals G1 L. So, isolate na natin yung S1 na to. Bring out natin. So, G1 minus G2 equals G1 L. So, ma-isolate na natin ang S1 by dividing both sides. So, G1 minus G2. So, cancel to. We got our equation for S1. And let's get yung equation for S2. Pwede na lang natin gamitin yung mga equation na to and equation na to. Yes. So, let's manipulate equation 2 para i-isolate si K. Para yung K na yun, isi-substitute natin sa K na to. So, let's do that from equation 2. We will get yung value ng K. Let's isolate K. Nagiging siyang ganyan. So, let's call din equation 3. Ilipat natin yan sa equation 1. Put equation 3 in equation 1. Equation 3 in equation 1. So, equation 1 is G2 equals negative 2. Then, ano yung K? Gagawin na natin siyang equal sa equation 3 na 2S1 S2 KS2. So, ito na yung equation natin, but dalawa yung variables. So, since this is to get S2, yung S1 ang express natin in terms of S2 by using L minus S2 is S1. So, let's substitute that. Negative. Pwede na natin i-cancel pala itong 2. Ay, sorry. Alisin na natin ito dito. So, the answer is negative G1 over L minus S2 times S2. So, hindi naman pwedeng i-ganyan yan dahil quantity ito. Hindi mo yan maka-cancel. So, what we can do with this, cross multiplication again. So, G2 L minus S2 equals negative G1 S2. So, distribute G2 L minus G2 S2 minus G1 S2. So, put together yung similar or put together yung S2. So, anong ililipat natin? This one, papunta doon. So, G2L equals positive na to. So, G2 S2 minus G1 minus, where are we? Minus G1 minus G1 S2. Isolate na natin si S2. G2 minus G1. So, S2 will be G2L over G2 minus G1. So, this is our formula for S2. Ayan, nakuha na natin yung formula for both S1 and S2. Ano pa yung mga points na kailangan nating makuha? That is for, ang S1 at S2 ay for the location, horizontal location ng summit. What if we also need yung other points along the curve? Like itong point na to, point na to, point na to, but they are not the summit. So, we can use yung relationship na ang sinasabi ng ng equation na to, ang sinasabi nito is yung vertical dimension from yung point na ina-observe mo up to the tangent is y. Ito yung y. And then, yung horizontal distance ng y from the reference point is x. Then, pag i-relate mo sila, parang proportion nila is, ayun nga, y over x squared. So, pwede mong gamitin to proportion yung other points ng curve. So, for example, is yung h. Proportion na din yung h dyan. So, h is equal to L over 2 squared. So, bakit siya ganyan? Kasi, kung sa point along a curve, ito yung y niya, this one, and then ito yung x niya. For h, yung midpoint ng curve is dito, up to the tangent is h. Ang horizontal distance naman niya from the reference PC is L over 2. That's why ito yung y, ito yung corresponding x squared naman for h. I hope na intindihan nyo iyon. So, using this equation, we will be able to get yung mga position ng mga points, all points along the curve. So, kunwari, meron kang another point na ine-evaluate. Kunwari, let's call point 2. Kunwari dito. Nandito yung point 2 na observe natin. Point 2. Okay. Point 2 na lang. I-observe na mo itong point 2. So, ano ang magiging dimensioning niya? Tawagin natin ito yung x niya. Magiging x sub 2. And then, ito yung corresponding y niya. Y sub 2. So, kung i-relate mo yan dun sa point natin, itong kaninang point, paano ang proportion nilang dalawa? So, it will be y x squared is to y 2 over x2 squared. So, na equal din proportion sa h over L over 2 squared. So, kung meron kang point 3, para lang malinaw sa lahat, so, kung may point 3 naman tayo, nandito naman. This is point 3. So, corresponding x niya is ito. Let's call x sub 3. And then, meron din siyang corresponding y. Let's call y3. So, proportion nila is yx squared. Yung first point natin yon, y sub 2, x sub 2 is squared equals y sub 3, x sub 3 is squared. So, proportion din yan sa h over L over 2 squared. So, ayun, ulit-ulit lang sila. So, ayan, nakumpleto naman natin yung lahat ng equations na kailangan natin for in solving parabolic curve. So, meron tayong formula for S1, S2, meron tayong formula for H. Oh, wala tayong H pa pala. So, eto, nakuha natin yung para sa X and Y. Kaso, wala pala tayong H. So, we need to derive a formula to define yung H. So, medyo magulo na yung diagram natin. Let's try drawing tayo ng isa pang curve. So, drawing natin siya ulit dito. So, we will smoothen this using a parabolic curve. Start dito. Gaganon siya. So, okay. Parang review natin to. Ano yung mga points? Set up mo yung mga points. We have 3 points. PC, PT, PI. So, first property ng parabolic curves, horizontal distance from PC to PT is L, and then from PI equal ang distance ng PC and then PT side. Then third property is yung midpoint sa chord ng PC to PT. Magpo-form siya ng equal dimensions dito. So, meron kang H doon, equal yan sa H dito. Now, we're trying to get the value or formula for H. So, let's add pa pala yung iba. Like, this one is G1. This is G2. This is, again, the back tangent. This is your forward tangent. Ano pa yung ililabel natin? So, pwedeng gawin natin yun sa pa-fill in the blanks natin sa quiz. Yung parts ng parabolic curves. So, ano pa yung hindi natin nalilabel? I think we've put na everything. So, let's put in S1 na. Kunwari, ito yung highest point. This will be your S1. This is your S2. Now, let's find H. How do we define H? So, from this one, we will use yung principle naman ng similar triangles. So, extend natin tong line na to. And we are able to form a big triangle. So, ito yung big triangle natin. Joining PC, PI, and PT. And let's call this point 1 dito. So, first triangle is triangle PC number 0.1 and PT. So, ito yung mga vertex. Yan. So, as you can see, meron tayong smaller triangle dyan. Vertical to, no? Vertical yan. So, ano yung smaller triangle? So, ito siya. This is the smaller triangle. Ilagay natin siyang yellow. This is your small triangle. So, let's call small triangle PC, PI, and let's call this point number 2. And then 2. So, makikita nyo, similar triangle sila. So, ano ang property kapag similar triangle? So, parang proportion din sila. Parang yung parabolic curve. Yung x and y sa parabola, y is to x squared. Dito, pwede yun, pero hindi naka-square yung denominator. So, we can relate yung h using yung smaller triangle muna. 2h is 2 L over 2. And then, para sa big triangle, what is this dimension? So, let's get that dimension. So, let's use yung sa math natin, rise over run. So, this is a continuation sa grade na G1. And then, ito pa rin is G2. So, makukuha natin ito by rise over run. This is your rise. Ito yung run. G1 is equal to rise over run. So, what is your rise? Ito yung hinahanap mong x. And then, ano yung run? It's L over 2. So, let's get x. Ito yung x natin. And then, para dito sa baba naman, to get that, G2 naman. G2 is equal to rise over run. But remember, G2 is negative. And then, ano yung rise? Yun yung kinukuha natin. Sabihin natin, let's call it x. So, run niya is L over to den. So, yung x para dun is G2 negative L over 2. So, lagay natin G2, negative G2, L over 2. So, pag pinagsama mo yan, it will be the complete height para makompleto yung ano natin, similar triangles. So, ano equation para sa similar triangles ng big triangle? So, height L over 2, G1, G2, and then ano yung denominator? It will be total length L. So, ito yung equation nila. Ito yung similar triangle equation natin. So, through this similar triangle, we can derive yung value ni H. So, now, let's isolate H. Anong pwede natin gamitin? Simplify natin to. This is 4H over L equals cancel tayo ng isang L. So now let's isolate H. 4H times 2 equals L G1 minus G2. Isolate H. This is, yung dalawang to ay 8. So, L, ano ba to? G1 minus G2 all over 8. So, ito yung formula for H. So, let's have problem na. So, example number 1. Example number 1, 4 symmetrical parabolic curves. So, a symmetrical vertical summit curve. So, sinabi na niya, symmetrical yung curve natin. Then, vertical siya, summit siya. So, paano ang drawing yan? So, ganoon. It's a summit curve. So, a symmetrical vertical summit curve has tangents of positive 4% and negative 2%. The allowable rate of change of grade is 0.3% per meter station. Stationing at elevation of PT is 10 plus 20 and 140, and elevation niya is 142.63 meter respectively. So number 1, compute the length of the curve. Compute the distance of the highest point of the curve from PC. Compute the elevation of the highest point of curve. So let's identify yung mga given. Number 1, let's get yung length ng curve. So, how do we get yung length ng curve? So, dun sa mga na-derive nating formula, walang length of curve formula doon. Pero, given naman tayo na merong change of grade na 0.3% per meter station. So, we've stated kanina na per station is equivalent to 20 meters. So, every 20 meter may change of grade tayo na 0.3%. So, we can put that into an equation na R is equal to G1 minus G2 over N. So, R is yung rate of change ng grade, and then N is yung equivalent number of stations. So, let's substitute. R is 0.3%, and then yung grade natin for G1 is 4%, and then minus G2 na negative 2% all over number of stations. So, makukuha natin yung number of stations, equations nito. So, performing yung operation, we can get N equal to 20 stations. So, kung may 20 stations tayo, and then kada station is 20 meters, ang magiging total length ng curve natin is 20 stations times 20 meters. So, meron tayong length na 400 meters. So that answers number 1. Number 2, compute the distance of the highest point of curve from PC. So we need to draw dito yung yung curve na. So start natin sa mga back and front tangent, forward tangent. Then label yung points. This is PC, PI, and then PT. And then nakuha natin yung length ng curve na 400 meters. Ang binigay yung station ng PT, it is 10 plus 0.20, and then binigay yung elevation niya 142.63 meters. So that's for PT, point PT. Ngayon hahanapin natin yung distance of the highest point of curve from PC. So from PC tayo, ano ang distance if manggagaling sa PC? That will be S1. So kunwari nandito yung, say dito yung summit or yung highest point, ito yung S1, and then this will be S2. Then meron tayong grid na 4% dito and then 2% dito sa side ng PT. So ano yung equation natin to get S1? G1 times L over quantity G1 minus G2. So substitute, G1 is, so kapag yung kanina sa number 1, hindi natin hindi natin kinonvert yung mga percentage values. Sa number 1, hindi natin kinonvert yung mga percentage values. Ginamit natin sila direkta dito. Kasi ang walang unit ang number of stations naman. Pero dito sa number 2, sa formula may kasama silang linear unit, which is yung length, which is in meters. Itong S also in meters. So kapag ganon, we need to convert yung mga grades into decimal value nila. So G1 will be 0.04, L is 400 meters, G1 is 0.04 minus G2 na negative 0.02. So doing the operation, S1 is equal to 266.67 meters from PC. So ito yung S1, 266.67 meters. So evaluate your answer. S1 is 266.67. So ibig sabihin lampas siya dun sa kalahati ng length. So ibig sabihin tama yung assumption natin na lampas siya sa PI. Dahil dito yung half ng length. Ito yung L over 2. And then ito yung L over 2. So S1, lumalampas siya sa PI. Wala siya sa left side ng parabola. Nasa right side siya ng parabola. So S2 will be, ano ang magiging value ng S2? Ayun. Saglit. Ay. Saglit. Ba tayo lumipat? So, anong magiging value ng S2? It's 400 minus 266.7. So, that is equal to 133.33 meters. Ano nga bang kinukuha natin sa number 2? We're computing for the distance of the highest point of curve from PC. So, that is S1. So, we've answered na pala number 2. So, the distance ng highest point from PC is 266.67 meters. So, number 3, yung elevation ng highest point of curve. Ano ang need nating dimension para makuha yung highest point ng curve? Since we are given yung elevation ng point PT, ito siya. This is 142.63 meters. So, we can use yung rise over run. Slope is equal to rise over run. Makukuha natin itong height na to. Height over run ng grade -2 grade ng forward tangent versus yung S2. So, makukuha mo yung height na to. And then, pag nakuha mo yung height na yan, you need to minus some portion na to. Itong portion na to, kailangan mong i-minus. Yun yung magiging elevation ng highest point ng curve natin. So, makukuha naman natin to using yung yung squared property ng parabola. Yung y is equal y over x squared. So, gawin natin. So, let's get first itong height na to. Vertical height na to. Number 3. So, to get that, gagawin nga natin yung slope. Rise over run. So, slope G2, since nasa right side tayo, side ng PT. So, G2 is equal to rise. Ano yung rise niya? Actually, yun yung hinahanap natin. So, let's just write rise. Rise over run. So, ano yung magiging run natin sa triangle na to? It is S2, where S2 is equal to 133.33 meters. So, G2 is 0.02. So, converted into percentage kasi nga may linear unit tayo. So, makukuha natin yung value ng rise. So, our rise is equal to So, rise is equal to 2.667 meters. Next, kailangan natin kunin na, ito na yung rise natin. Let's put 2.667. So, next natin kukunin is this dimension. This is y, diba? Para yan ang i-minus natin, makukuha yung elevation. So, paano natin kinukuha yung y? Yung squared property nga ng parabola. So, y is x squared. So, paano na natin siya ipoproportion? Siyempre, dun sa h. Gaya kanina. So, h is L over 2 squared. Pero, wala pa tayong value ng h. So, formula for h is L over 8 G1 minus G2. So, substitute. L is 400 divided by 8. G1 is 0.04 minus G2 is negative 0.02. So, H is equal to 3 meters. So, nasa si H. Isa-substitute natin si H dito pala sa formula. So, meron tayong L. Meron na 400. Meron tayong X. Ang gagamitin natin X is, since nasa side tayo ng PT, we will use S2 na X. This is S2 na equal to 133.33 meters. So, given na lahat ng values, makukuha na natin si Y. So, pwede na natin i-shift solve yan. Ang makukuhang Y value is 1.33 meters. Now, makukuha na natin yung elevation ng summit or yung highest point ng curve. So, from the elevation of PT, so, from elevation of PT, i-add muna natin itong height na 2.667. So, plus 2.667 meters. And then, ima-minus natin itong maliit na Y. So, nakarating tayo dun sa summit point. Minus, ilan ba yung Y? 1.33 minus 1.33 meters. So, all in all, elevation is 143.97 meters.